In part B, estimate the absolute error in approximating natural log 1.2 with the third order Taylor polynomial. From the function f of x equals the natural log of 1 minus x, and we're going to approximate the value the natural log of 1.2. Therefore, we're going to find out what is the x value that we're going to use in this problem, or equate 1 minus x equals 1.2. We get x equals negative 0.2 and set it aside. And we are going to use the third order Taylor polynomial, or P3. So then the absolute error is the absolute value of the R3, which R3 is the function f of x minus the P3. Or we can say the absolute value of the natural log 1.2 minus the Taylor polynomial degree 3. To estimate the absolute error, from the formula in part A, the Rn equals negative x to the power m plus 1 divided by m plus 1 times 1 minus c to the power m plus 1. For R3, we have negative x to the power 4th divided by 4 times 1 minus c to the 4th. For c between x and 0. Absolute error, which is the absolute value of the R3, equals the absolute value of negative x to the 4th over 4 times 1 minus c to the power 4. And in our case, to approximate the natural log of 1.2, we already set aside the x equals negative 0.2 in this case, and 0.2 can be used into the formula here. Therefore, the R3, the absolute value of the R3 would be the absolute value of negative 0.2 to the 4th power divided by 4 times 1 minus c to the power 4. And now the c that we can use in here could be any value between x and 0, which means between negative 0.2 and 0, could be including the negative 0.2 and 0 as well. So then we look for the number that will give us the magnitude or the upper bound of this. As c between 0 and negative 0.2, the largest quantity of this quotient that would be from c equals 0. So we should c equals 0. Therefore, the absolute error will be bounded by the value 0.2 to the 4th. Negative side will be gone since you raise to the 4th power divided by 4 times 1 minus 0 to the 4th. And this becomes the value 0.004, which is the estimate of the absolute error.